Alright, next let's talk about multiplying rational expressions. Let's start with something simple off of one of your self-starter problems. For example, we might do any of these reduce later? Yeah, like this one. On your self-starter problems, you had a 12 over 13 times 1 over 4. Okay? Example number 3. So this is not actually part of your self-starter. We did the self-starter, that's on one paper, and then you should be kind of maybe doing notes, a few notes. This is all review though, so if you don't want to write everything down, you're mostly just absorbing and remembering, that's fine, okay? Alright, so multiplying fractions, what does that mean we do? This is confusing because it's not an x, it's a multiply. Here, I'll turn it into that.
You go across.
You just go straight across. So 12 times 1 is 12, and 13 times 4 is 52. And then, can we reduce that?
Yes.
Yeah, because 12 is 4 times 3, and 52 is 4 times 13. We just did that. And so the 4's cancel, and we get 3 over 13 for our final answer. Now, did it seem kind of silly that we multiplied first and then ended up dividing again before, so we could reduce it?
No.
Did that seem a little bit silly to multiply 13 times 4 and then divide them again just so we could reduce it? It didn't seem silly to you?
No.
Well, it doesn't when you're working with numbers, but it's not going to work once we throw in algebraic expressions. So here's how a better way of maybe doing this problem, and I'm going to use a dot instead of the x. Okay, maybe a better way of doing this problem is to factor it first. So that before you even multiply anything together, you factor everything that will factor first. So what are the prime factors of 12? 2 times 2 times 3. Prime factors of 13. 13 and 1. Prime factors of 1. Prime factors of 4. 2 and 2. Now since this stuff is all going to become top of this problem, and this stuff is all going to become the bottom of that problem, I don't even need to multiply it together. I don't even need to write this step if I just imagine that this is all on the top and this is all on the bottom, right? So then can you cancel any terms? You can get rid of the 2's, and therefore you're left with 3 over 13. Same answer, right? Okay, that's the process we're going to take with what we're doing today. So let's go to a new page, example number 4. We're going to do 4x squared over 4x minus 16 times x cubed minus 64 over 2x. Now, since this says multiply, we know we need to multiply across. But seems kind of weird to divide before you multiply, but that's what we're going to do. We're actually going to factor everything first. Now, I don't care if you actually do prime factors, which is what we did on the last problem, but you do need to keep in mind that all of these little pieces can kind of factor out separately, so just kind of keep that in mind. Okay, so we're going to go ahead and factor everything that we can first. So I'm not going to worry about factoring the 4. If I really need to, I know that's 2 times 2, right? I mean, you could write it as 2 times 2 times x if you want to write it out that way. Do you want me to? Okay. Let's go ahead and do prime factors then. So isn't 4x squared the same thing as 2 times 2 times x times x? Yeah. Now, can we factor this thing? This is called a difference of cubes. We've seen this before, but we always forget it. So this is x cubed minus 4 cubed. 64 is 4 cubed. So that means we can use our difference of cubes formula, which says x minus 4, a minus b, times a squared, x squared, plus a times b, so 4x, plus b squared, so plus 4 squared, which is 16. And then this thing will be prime. What does that mean if it's prime? It doesn't go any smaller. That's it. Okay, so that's the pieces on the top, right? And since it's multiplying, it's just going to be this times this, so is it okay if I just kind of multiply, put it all together as one numerator? Is that okay? Alright, Alright, now let's factor the denominator. Does anything factor out of this? 4, yep. So then we have x minus 4 left. And then this is already kind of prime factors 2 times x, right? So we've factored everything in the numerators and just put it together. We've factored everything in the denominators and just kind of put it together. Now we can get rid of common factors. So maybe I didn't really need to do the prime factors of this 4, because both of those 2's can go away with that 4. Maybe I should have turned the 4 into a 2 times a 2, but I think it's getting too picky, because you can do that kind of stuff in your head, right? Okay, now do we have anything that cancels this other factor, this x minus 4, right? What about the 2? I think that 2 has to stay there, because those 2's reduced with that 4, because 2 times 2 is 4, so 4 on the top and 4 on the bottom. There's no other 2's up there to get rid of that one. However, there is an x we can get rid of with that x, yes? Because these are all just individual factors. Now we just take what we have left and put it together. So we have x, and we have x squared plus 4x plus 16. And we have 2. And I would say that answer could be done at that point, but if you really wanted to, you could rewrite this as something like x cubed plus 4x squared plus 16x. And you could even change that so it's not like all a big fraction. You could just put a 1/2 in front of that if you want to. So it's just, I don't know, if you want. You don't have to do that. In fact, you could even multiply that half through there, couldn't you? 1/2 x cubed plus 2x squared plus 8x. I don't know. I think that looks better than that, but I don't care. As long as you get rid of all the common factors, I don't care if you leave the answer like this or multiply it out like this. It's fine either way. Okay. Now dividing is a very similar thing, because dividing is just multiplying where we copy and then multiply and then flip over the other one, right? So divide. Do we want to go to our self-starter to get a division sample, or are we good? Yes? Okay. So divide. So here's example number 5 from our self-starter. Which one do you want? So 1 over 3 divided by 3 over 5. So then I had a student teacher once that said she learned this. Copy, dot, flip. What do you think that means?
You copy, then put a dot, and then you flip it.
Copy the first one, put a dot, flip the last one. And then what? Then it's just multiplying. Are there any common factors we can get rid of first? Nope. So now we just multiply across, so 5 and 9, and there's the answer. Okay, let's do a harder one. 4 minus x over 4 plus x divided by 4x over x squared minus 16. It's just division. What do we do?
Dividing.
Okay, so what did I tell you to do to divide?
You flip it.
Copy, dot, flip. Now it turns into a multiplication problem. So now where do we go to remember how to do this problem?
The multiplication spot.
We go to the multiplication section of our notes to see what we did next. So what was the next thing we did? We factored next. So we have 4 minus x. And does this thing factor? Yep, that's called what? Difference of squares. Good. Okay, now we should go through and see if anything will reduce. this x plus 4 and 4 plus x? Is that same thing? Yeah, it's just flipped around. What's your idea?
What if you time, like, back to the bottom by -1, right? And then you do the 4 plus x root, cancel out the x minus 4. And then,
No, because if you do that, you'll end up getting a negative x plus 4, so it still doesn't match.
right.
And it already cancels with that anyway. So. But cool, I'm glad you're thinking. Okay. So, sorry, not that he doesn't normally think. Okay, alright. So then if you want to, could you multiply this whole thing out?
No.
Don't you have to?
Why you boil the top?
You don't have to. Okay, so you could leave it like this. You could leave it like that, but keep in mind that the back of the book, when you look up the answer there, they might FOIL it out. So if we do 4 times x and -4 times -x, we get negative, okay, and then we have a negative x times a positive x. So that's negative x squared plus 8x minus 16 over 4x. Alright, so multiplying and dividing are similar processes, you just write it down differently.